Okay, here's verifying identities. Okay, so now then, I can see that this on the left-hand side looks like a difference of squares. So I can write this, okay, cosine squared x plus sine squared x, and then cosine squared x minus sine squared x. It's just like doing something like this. X squared minus 4 is the same as x plus 2, x minus 2, okay? I just basically square rooted the cosine, square rooted the sine, okay? So the cosine to the power 4 becomes cosine squared. And again, just like over here, 1 plus and 1 minus, okay? So that's what I get. Now, this here, that's 1, okay? Right, okay, now then, based on the fact that, of course, it's 1, I can replace the sine x over here, sine squared x, with 1 minus cosine squared x. That's 1 minus cosine squared x, okay? In other words, there you go. So sine squared x is that, okay? So I've got the 1. I now have cosine squared x here, minus, and again, remember, I'm going to replace this sine squared x with 1 minus cosine squared x, okay? Right, so I don't really need the 1. Cosine squared x, negative cosine squared x, double negative, I add them, so that's 2 cosine squared x, and there's the minus 1, and that is exactly what I've got up there, okay? Right, on to the next one. Let's erase all this. Let's look at this bottom one here. Now, this looks like it's got some double angles in it, so you need to kind of look at the double angle formulas for this. Okay, so cosine, let's go, cosine 2x, that is 1 minus 2 sine squared x, okay? Sine of 2x is 2 sine x cosine x, okay? So I've just done all of that. I still have plus sine x over cosine x, okay? Right, I need a common denominator here if I'm going to add these. Now, the common denominator is this, so I'm not going to change this particular rational expression, this fraction. Got people outside. Right, 1 minus 2 sine squared x over 2 sine x cosine x, okay? Plus, right, if I have a common denominator of 2 sine x cosine x, then can you see, if this was the original denominator, this is the new part. So if I put 2 sine x with the sine x on the numerator there already, I'll end up with 2 sine squared x, okay? Because it's the sine x with an extra 2 sine x on the top. That's 2 times squared x. Now, look what's going to happen here. This is your common denominator, but look at this. Negative 2 sine squared x plus 2 sine squared x, okay? That's going to leave me with 1. So I'm going to have a 1 as my numerator. Now remember, if this is the common denominator, we've already said that that is sine 2x. Remember, that was what that is. So I'm going to write sine 2x back in place. Now, of course, that is cosine 2x. Remember, flip it upside down, it becomes that. So that's what that is. Okay, let's take a look at this. Convert the complex number to trig form. Now, again, this is not too bad. The actual math is easier than it actually looks. So, here we go. We're going to find the radius, okay, r. So again, like earlier, r is the square root. Now, you can think of this as a plus bi. You can think of the 3 root 3 as, let's say, the x, and the negative 3 as the y, okay? So, what is 3 root 3 squared plus, again, it's like doing Pythagoras' theorem again, the negative 3 squared. Okay, so this is 27, this is 9, that's 36, the square root is 6. So, we have r equals 6, okay? Again, I just used Pythagoras' theorem with 3 root 3 and negative 3. Okay, right, what do we do next? Okay, still on this. Okay, so we have this. We need to find out what the actual angle is, okay? Theta. Right, now this is just this. It is just y over x, that's the tangent of theta. Y is the -3, the x is the 3 root 3, so basically this is what tan theta is. Now we can cancel the 3's there to give -1 over root 3. We can rationalise denominators to give root 3 over 3, so that is what I get for the tangent of theta, okay? So I need to do the inverse of that. Now that, root 3 over -3, is actually, check on your unit circle, okay? Well, first of all, let's just double check where this is. If x is positive and y is negative, okay, which we have here, then that's going to put us somewhere in this quadrant. Now that is, so the inverse tan of negative root 3 over 3 is, it's going to be, well, this is actually 30 degrees, but of course negative 30 degrees, pi over 6 if I'm right in radians, okay? So this here is negative pi over 6 or negative 30 degrees. So of course the angle must be 330 degrees, okay? So what I've actually got for my final answer, in other words, write this in trig form, polar form, is going to be this right here, okay? So remember, r is the radius, and then we have cosine 330 degrees plus I sine 330 degrees. Okay, so remember, we got this by using Pythagoras' theorem on 3 root 3 under -3, okay? And then we got this by just figuring out what -3 over 3 root 3 was as a tangent, okay? And that came to be 330 degrees, and that's how you write the answer.